In this video, we're going to look at how to simplify a fraction or reduce a fraction to its simplest form. Now, there are several ways we can do this, but most of them involve factoring, and which we talked about in previous videos. So let's take a look at how we found the greatest common factor of two numbers. Now, to find the greatest common factor of 6 and 8, one way you can do is to make a list to find all the numbers. Factor means a number that can go into 6 and also can go into 8. So you can list all the numbers that can go into 6. For example, 1, 2, 3, 6 can go into 6. And then you list all the numbers that can go into 8. That's 1, 2, 4, 8. And then you will be able to see that the number 2 can go into both of them. So that is the greatest common factor. We also talk about a different way we can break down 6 as 2 times 3. And we can break down, actually the mathematical terminology should be factor. You can think of it as breaking down 6 as something times something. And we can also factor 8 as 2 times 4, and then 4 can be factored to 2 and 2. So we have to continue to do this until none of these numbers can be at each branch can be factored any further, can be broken down any further. And when we write the numbers, we want to line up the same number. If they're different, don't put them in the same column. And after you line them up, you will be able to see they both have 2 in common. So this is another way. So usually this way is better for bigger numbers. For smaller numbers like 6 and 8, I think a lot of us can already see 2 goes into both of them. So the GCF for 6 and 8 is 2. Now for big numbers, it might be a little bit harder, but some of you may be able to see 8 can go into both of 16 and 24. So we're going to use the factoring method. So first we break down 16. So 16 is 4 times 4. You can do 2 times 8 if you want. And notice each branch can still be broken down further. Now check each branch. None of them can be broken down further, so you can stop. So we're going to write down 16 as 2 times 2 times 2 times 2. Now for 24, we can do 4 times 6 or 3 times 8 or 2 times 12. But each branch 4 can be broken down, 6 can be broken down, but when you check those numbers, 2, 2, 2, 3, none of them can be broken down. So when we write down these numbers, 2, 2, 2, 3, now make sure you only put the same numbers in the same column. So the first 2 can go here because they match. The second 2 can go here. The third 2 can go here. But the next one is a 3. I cannot put 3 here because it doesn't match that 2 there. So I'm going to create a new column, put 3 in the new column. Now let's take a look at the number, which column has 2 numbers. So 1 here, 1 here, 1 here. Now these 2 only has a single number. That means this 2 can only go into 16. This 2 cannot go into 24. A single 3 means this 3 can only go into 24. It cannot go into 16. But these 3 2's, because they appear in both of them, so they can go into both 16 and 24. 16 and 24. So these are the numbers we're going to bring down. GCF. So we have 2 and a 2 and a 2. And we multiply them, we get the answer 8. All right, so similarly, we can do the same thing with the 6 and 27. And the 6, 27, the breakdowns are not too difficult. 6 is 2 times 3. 27 is 3 times 3 times 3. So when I write down these 3 3's, I cannot put my 3 here because they don't line up. And they don't match. So I'm going to put my 3 here because they match. And then for the other 3's, I'm just going to have to create a new column for each one of them. And now we're going to look for a column with 2 numbers. And notice we have this column with 2 3's. So that means this 3 can go into both 6 and 27. So the GCF, we can only bring down this 3 because that single 2 means this 2 cannot go into 27 because it's missing in 27. And this 3 is missing in 6. So this 3 can only go into 27. It doesn't go into 6. Same for this 3. So the second column, because we have 2 3s, that means this 3 can go into both 6 and 27. So that's called the greatest common factor. Okay, so this is a review of greatest common factor. So now when we simplify fractions, we can, when we have 6 and 8, if you remember what we just did, so you can try to find the greatest common factor, the biggest number that can go into 6 and 8. So we already know it's 2. And then we divide both numbers by 2. 6 divided by 2 is 3, 8 divided by 2 is 4, and that is the answer. Same thing for 16 over 24. So we already did the greatest common factor, which is 8. So we're going to divide both top and bottom numbers by 8. 6 divided by 8, 2. 24 divided by 8 is 3. And we can do the same thing. And when we already know the greatest common factor of 6 and 27 and is 3. So we're going to divide both the numerator and denominator by 3. 6 divided by 3 is 2. Negative 27 divided by 3, negative divided by positive is negative. So we got negative 9. And when we get here, usually we would like to move the minus sign because the top is positive, nothing means positive, the bottom is negative. And we know a positive divided by a negative will give us negative. And so this is like opposite of credit, it's that. So that gives us negative 2/9. So we like to move the minus sign, put in front of the whole fraction. And this method also works with expressions with variables. So first, when we have x divided by x, it's kind of like you look for what they have in common, x and x, of course, and they both have x. So the greatest common factor is x. And so we can divide both the top and the bottom by x and to get 1 over 1, which is 1. But if you really think about it, this literally means x divided by x. So any number divided by itself, you will get 1. Okay, so this is something we probably should keep it in mind because we often have to use this. Whenever you see the numerator has x, the denominator also has x, and they match, when you divide an x, again, x represents a number, a mystery number, but it doesn't matter which number x represents. And both two x's represent the same number. So if they're the same number, whether it's 2 over 2 or 3 over 3 or 4 over 4 or 5 divided by 5, 6 divided by 6, it could be anything. It's always going to be equal to 1. So this tells us it doesn't matter what number x represents. When we divide x by x, we always get 1. So if we keep this in mind, now we can simplify a complicated expression like this. So when we have a mix of numbers and variables, and again, it looks like still looks like a fraction, although we have a different name, and we call it rational expression, but you can think of it as just as a fraction. So when we simplify them, first we will simplify the numbers. 50 divided by 15. Now, how do we simplify then? You can do the same thing we did previously to find the greatest common factor. Say one number can go into both 15 and 50, and that is 5. So you could first reduce 50 over 15 by dividing both the top and the bottom by 5. So that gives you 10 over 3. And then with the variables, and just keep using example 4. If you found the same letter that appear both in the numerator and denominator, and you always end up with a 1. So we look for so we see an a here, and the bottom there's a. So these two a's, it's kind of like a divided by a number divided by itself, it's 1. And similarly, we have two b's. So you have like b divided by b, it's still 1. So it doesn't matter whether it's x over x, a over a, b over b, you always end up with 1. But because we don't really have a c in the bottom, so that c will have to stay. So what I did is I found out I divided, so I noticed, okay, 5 is a number that can go into both 50 and 15. and they both have A's, and they both have A's and they both have B's, so that's the greatest common factor. Again, because both of them have 5, both of them have A, both of them have B, the numerator and denominator, so you can get rid of what they both have. So that's called, it's kind of like both of them will throw out what they have in common, and so what's left will be the simplest. And after that we get 10c over 3. A quick way to do it is, again, you can do this in your mind. So you could literally divide this by 5, divide this by 5. So that gives you a 10. This 15 divided by 5 gives you 3. And then a and a, they just cancel out because a divided by 8 gives us a 1. But remember, anything times 1 will be itself. So this 1 doesn't really do anything. But if you want to put a 1 there, you can. And b divided by b, you also get a 1. And the c, there's no c to divide by, so you will have to keep it as a c. And then you can have to get rid of the 1 and 1, because 3 times 1 is 3, times 1 is still 3. So these 1s don't really do anything. So you literally just kind of like crossing a and a's out, b and b's out. So you just get 3, which comes from 10, top 10, and the c. Sorry, this c should go in the numerator. So the top you will have the 10 and the c. The bottom you will have just a 3 because a is crossed out, b is crossed out. So that's how we get that answer.